All right, let's look at an example of logarithmic regression. Okay. We have our function f of t equal to this fraction with an exponential piece in the denominator, describing the number of people who have become ill with influenza T weeks after its initial outbreak in a town with 30,000 inhabitants. We want to know how many people, so we're looking for how many people became ill with the flu when the epidemic began. Okay. We have two variables going on in our original function. Okay. It says f of t is the number of people who are ill. And then it says t is weeks. So t equals time in weeks. So when we're looking at our first one and it says how many people, that means that we are going to find f of t became ill with the flu when the epidemic began. When an epidemic begins, when anything begins, we start with our time equal to 0. So this means that we need to find f of t, or our function, when t is equal to 0. All right, so we're going to have f of 0, which means that we're going to plug 0 in wherever we see a t in our equation. So we're going to have 30,000 all over 1 plus 20 e to the negative 1.5. And instead of t, we're going to plug in 0. Then we're going to go to our calculator. I am again using desmos.com. /graphing. But you can use pretty much any scientific calculator you need. I'm going to start with my division. I have 30,000 all over 1 plus 20. And then you can look in your functions button, scroll down to calculus for your exponential, or you could go to your ABC and do, where'd it go? There it is. E, and we need E to the negative 1.5 times 0. And we wind up with, oops, let me move that this way just a little bit. There we go. 1,428.57 people, but we're not going to have part of a person. If you want to have part of a person, go to statistics. We're in college algebra, so we're going to round. This is going to round up. So we're going to say that 1,429 people were ill. Okay? And you need to actually start writing these things out, because if you are doing research or work actually out in the real world and not in class, if I just went up to my boss and said, the answer is 1429, the boss is going to look at me and go, 1429 what? Monkeys? Bananas? Minions? Okay, so you got to be able to explain what you are finding and why it matters. Let's look at part B. It says how many people were ill. So if they're asking how many people, we know we're trying to find f of t. And it says end of the 4th week. So end of the 4th week means that t is equal to 4. So this time, we're trying to find f of 4. So every time we see n t, we are going to plug in 4. So we wind up with 30,000 all over 1 plus 20 e to the negative 1.5 and plug in our 4. And when we go to our calculators, you have to show me how you plug everything in, but you don't have to show me any work from here. If you're working in Desmos, we can highlight the 0 and replace it with a 4. And you can see that we have 28,582.996. Again, that's people. So let's go ahead and write our sentence. There were 2,858. We're not going to have 2.9 people. We're going to round that up. So that becomes a 3. The 9 is enough to round us up, just like the 5 was enough to round us up. So 28,583 people were ill by the end of week 4, which is kind of like what happened with COVID. It just exploded. One more example, or one more question in this example. It says, what is the limiting size of f of t, the population that becomes ill? So limiting size means the maximum amount. What is your ceiling? Maximum capacity, okay? And this is what China tried to do when the epidemic began with COVID, was to shut down all of the borders, keep it contained, okay? So for this town, if they were to lock down the borders and keep it contained, the only people that would be getting sick are the people in the town. There are 30,000 inhabitants in the town. So 30,000 people in the town, which means that the limiting size for the maximum number of people that can be sick is 30,000. If our town had 1 million people and we had the limiting size for the town, limiting size would be 1 million people. The limiting size is however many people are there that can get sick, were ill when the epidemic began.